in biology.
I'm in biology class right now.
Are you?
Yeah,
The class is all memorization, man. It's
I like biology.
You like biology or you don't like biology?
I like biology.
Oh, nice. Yeah, no, it's a cool class to learn about like how the world works. I guess it's quite fascinating to see how the human body does stuff. But
Yeah,
I like numbers and stuff. It's kind of more my thing.
really.
All right, what's up? So you here? Can you see Actually, let's try something. Because
I can watch the stream through my laptop.
Oh, nice. Yeah. Okay. Yeah. Just do that.
I'm gonna leave it on. Twitch. Maybe later on today I'm gonna stream.
Oh, nice. Yeah. No, I
Um,
was having fun watching you earlier. Dude.
Bro, I hit my 100 views.
You did? Nice,
Yo,
dude. We just gotta get you up to 50 followers.
yo, I'm about to reach 20.
Yeah, dude. As long as you're just like consistently streaming, like people will.
We'll come eventually.
They'll come, dude. Build it, they will come, dude. That's what I always say, man.
Yo,
uh,
watching.
all right, nice. Okay. So can you see the?
The lesson 21 to 1.
Yeah, 27. This is what you guys are doing, right? Is factoring trinomials.
Yeah.
All right, cool. Here, let me show you how you do this one. So, the reason why they call it a trinomial. Do you know what tri means?
Nope.
What about trios? What are trios?
Okay,
Right? Tres, dude, 3. And then nomial is just another thing for numbers. So this is just a fancy word. When they say trinomials, it just means there's 3 sets of numbers.
So basically, it's an equation with three,
Good with
3 numbers, basically.
yeah, 3 different terms. So, well, this is a complex one. Where's the easy one you guys do? X squared plus 8x plus 15. Okay, yeah. So this is an example of a basic trinomial. So x squared plus 8x plus 15. Because what you have is right, 1, 2.
15, yeah.
You got 3 sets of things. And these are 3 things that can't be grouped together anymore, right? Because this stuff has x squared in it, this stuff has x, and this has a 15 in it. For instance, if I put let's say I put a 16 here, what could you combine the 16 with? Like if we wanted to simplify this. Because this right now...
With 8?
With the 8?
Yeah.
Well, the 8 has an x on it. You can only have things group that have the same variable on them, per se. So this is like 1x squared. This is 8 x's. And then this is 15 things with no x's. 16, right, has no x's on it. So the 16 can only really combine with the 15.
Okay.
So this would convert down to this, right? And that's how you can make something that looks like whatever this is, like a quadnomial or whatnot. It's really a trinomial because these 2 things could be combined.
Okay.
All right. If anything doesn't make sense, Mel, you got to yell at me too. You gotta be like, "Yo, Gio, I don't get it," because that's my job, dude. My job is always trying to. Because when you take classes with your teachers and whatnot, she's teaching to 30 people at once, and so if one person doesn't get it, she's just like, "Oh, I don't give a fuck. I'm just gonna keep moving on," because I got 29 other kids who get it, But the whole advantage to having someone who can teach you one-on-one is, if you don't get something that, I stop and try and make sure that you understand it.
Yeah.
In a way that makes sense. So okay, let's say we had this. Say we had x squared plus 8x plus 15 plus 6x. How would I simplify this?
So 16 plus 15.
So you want to add the 6x with the 15?
Yeah.
Oh, you can't do that because
because of the x.
The 6 has an x on it, the 15 doesn't. Which number here has an x on it?
Has an X or doesn't?
Does have an x. You need something with just a single x on it.
8.
The 8, good. So this can combine with the 8. That's why this becomes x squared plus 14x plus 15. Okay? Alright, let's try something else. Let's say I have 3x squared. How would I simplify this one right here? The 3x squared plus 2x minus 6 minus 2x squared. So you got to find like
3x plus 2x.
Mm-hmm.
And then
you have the minus 6, right? So this is what they call, Mel. They call us like grouping terms. Have you guys ever heard of that before? Grouping terms.
Sounds familiar.
Yeah. Grouping terms just means like combining things that look alike to be the same. The big example they do with that, if you had like 8x minus 2 plus 6x minus 4, you could group this by terms, right? Because you have the 8x and the 6x. These are like the x terms, right?
And minus 2 and
minus 4, right? Yeah. So that's why this would simplify to become 14x minus 6, right? Because the 8x and the 6x combine to become 14x. And then the minus 2 and the minus 4 combine to become minus 6. Yeah. Does that make sense?
Yeah, it looks pretty simple.
Okay, good. All right, so I'm gonna erase this. I know there's like a 3-second delay right between the stream and like what I'm saying. And yeah. There's a way we could have it not be like that. It's But does this work? How it works so far? Like, is the delay like super annoying? Because I can get rid of the delay.
No, it's good. It's good.
Okay, that's cool. All right.
You have the delay when you play video games, though they don't string snipe you.
Oh yeah. Well, that's just because, dude, like the computer has to compress all the data and then it has to throw it up on. It's a lot more work to throw all those frames onto a server and then have it stream. That's why it's a 5-second delay there. This, isn't too bad. This is, we're not playing an FPS here. We're playing math. So
yeah.
Okay, so Mel, how would I simplify this one right here?
X plus 2x.
He probably. Wait, so we're playing.
I'm really bad with math.
No, yeah, you're good. That's the whole point, is to get you better. So think about. So this is like a grouping terms thing, right? So let's look. What type of terms are there here?
3x.
There's a 3x squared, right?
Yup, and the 2x.
Good, and the
There's
2x.
2x.
Ah, but no, they're not both 2x, right? This is x squared. This is 2x squared. So what that means is...
I subtract 2x with 3x.
Well, 2x squared from 3x squared. Yeah.
And it's x2 plus 2x minus 6.
Yeah. I'm drawing with arrows. X squared plus 2x minus 6. Good, man. Yeah. That's literally what it is. Cool?
Yup.
All right. So this is always what I do when I tutor kids. Is I always we got to make sure that like you understand like the basic stuff, not basic stuff, but like the underlying stuff, before you can move on to the more advanced stuff. It's like leveling up your guns. You got to get like, the bullshit like muzzle brake first before they let you get like the agency suppressor.
Yeah.
Okay, so let's go into what factoring is. Okay, so factoring is kind of what the opposite of expanding is. So let's say, for instance, you had something that looked like this: x plus 3 times x minus 2. Have you guys been taught like how to expand this yet?
I think so. Not sure. It's
Okay.
because my teacher, what she doesn't explain that much.
Okay. Well, so these are what we call, these are binomials. Each one of these. Okay. You see why these are binomials?
Mm.
What does bi mean? Tri means 3. What do you think bi means? It means 2.
Oh,
So-
yeah, no, I did.
Yeah, so these are called binomials, Mello, because you got 2 terms here. You got an x and a 3, right? And then you got an x and you got a minus 2. So what they call this is, they call this binomial expansion. So if you have two expressions in parentheses right here, you can multiply them together. I think what they call it in your grade, do they call it FOIL? Have you heard of it being called FOIL?
Oh, the FOIL method.
The FOIL method. There we go. What does FOIL stand for?
Oh, I was trying to remember. First, outer, inner, and last.
Yeah, good. First, outer, inner, last. Yeah, very good. One sec. Where's my fucking webcam not working? This piece of shit. Come on. One sec. Almost. There we go. Okay, good. Yeah. So first, outer, inner, last. So usually what that means is like first times the outer, and then inner times the last. I honestly don't like the whole acronym FOIL because like it kind of doesn't make any sense to me.
Yeah.
So here's the better way that I like to do it. So let's say, for instance, you have x plus 3 times x minus 2. I like to kind of make what we call, this is called like a Punnett square. Have you guys done Punnett squares in biology yet?
Yeah.
Yeah, it's like kind of like a tic-tac-toe type thing.
Oh yeah. Yeah.
So what we do is you put each one of these terms in like the top, for instance, and then I put each one of these terms in the bottom down here. Oh wait, who's trying to call me? No, I'm in the middle of teaching. Come on, girl. Rachel trying to call me. Okay, so what we do is we end up multiplying each one of these things by each other. So what is x times x, Mello? What's another way to write x times x? Here's a good one. What if I say x plus x plus x? What's another way to write x plus x plus x?
Oh my god, bro, I'm being so retarded right now.
No, it's good. No, don't worry dude. So this could be called 3x, right? See how there's 3 of them? X plus x is 3x.
Yeah.
Okay. What does x cubed mean? What does it mean when they put this 3 above here? Like, not in front. What happens when they put it above?
So it's 3 times?
So that's x times x times x. That's what x cubed is.
Oh.
Yeah. That's what they mean when they put that up here. That just means it multiplies itself 3 times. So what do you think x times x equals then?
2x?
Not 2x. That would be x plus x.
No, yeah.
It's x squared.
It's squared.
There you go. So that's what we're going to do. So when we do this whole like Punnett thing, this little square, we're going to do this thing times this thing to get this one. So x times x is x squared. Okay. So now let's say we wanted to do this part of the square, right? I would be doing x times 3. What is x times 3 simplify into?
Square x.
No.
Oh, before.
So, all good, Mel. Well, as long as you're saying things, that's what I say is always the best thing, because at least you're responding. The worst thing, dude, is when I teach some kids, dude, and they're like, "Oh, I get it." I'm like, "No, you don't." Like, "Yeah, no, I get it." I'm like, "Okay, cool," and and then they never end up learning anything. You got to say the wrong things in order to be able to eventually say the right things.
To be corrected. Yeah.
Exactly. So that's all
So
good.
is
So 3
x
times
plus
x
x
is
plus x.
good, which is just 3x.
Ah.
So we can just write this as 3x. Okay, so knowing that, how do we think we're going to do this part of the square then? What's that going to be?
Negative 2x.
Negative 2x. Good, see? Yeah, see? So you're not dumb, Mel. You just got to remember things and pick it up.
Yeah.
Oh, dude, that's all math is, dude, is remembering shit. All right, what about this part of the square? What is it going to be?
Negative 2.
Mm-hmm. So remember, it's this negative 2 times what's up here, which is a 3.
3.
So what's negative 2 times 3?
Negative 6.
Good, negative 6. Perfect, dude. All right, cool. So now you're done, because what you did is you filled in all the spaces that you needed. So now all you do is you write each one of these things like this. So x squared, then I'm going to say plus 3x minus 2x minus 6. You see how I just wrote every single one of these terms, and I put them on the right here, but I just put them all in order?
Yeah.
Okay. Then you got one more step, which is you gotta combine terms. So how do we combine terms here to make this into a trinomial? So something that only has 3 numbers.
Negative 2x and negative 6.
So no. Remember, this has an x on it. This doesn't. So these
3x, negative 2x.
Good, Melon. Yeah, this one and this one.
So it ends with x squared x with plus x negative 6.
Good, perfect, dude. Yeah, there you go. That's it. So that's how you can expand 2 things in parentheses, multiplying, into a single trinomial. Okay?
So it basically was a 3-step.
It was a what, sorry?
3-step plus. A 3-step process.
Yeah. It's a 3-step yeah, exactly, yeah. But eventually, dude, you get so good at doing this that you don't have to think about it. You just do it, you know?
Yeah.
It becomes like a muscle memory thing. You don't really gotta. Okay, so here let's do. I always do this. I say, like, let's do another practice, because I want to make sure you get this. All right. Let's say we have x plus 4 times 2x minus 2. Okay, we'll make this a little bit harder. So the first thing you got to do is you got to make your square. So what am I going to put up here in the top part of the square?
You're gonna put, first is a 2x, one right
Good.
there.
2x. What else do I put up there?
And negative 2.
Good, negative 2. All right. What am I going to put here on the left?
X and plus 4.
Good, plus 4. Perfect, dude. All right. Now what's the next step?
X. What is it? X times 2x.
Good. Very good. X times 2x. And this may trip you up a little bit, right? Because usually we weren't having numbers in front of stuff when we did it. But this is slightly different. Okay.
So it's 2.
Yeah.
2 squared 2.
So
No.
this is gonna equal 2x squared.
2x squared.
So here's the rule with multiplying shit, Mello. So x times 2x is the same thing as x times 2 times x. Okay?
Okay, you got me straight up confused, but okay.
Okay. Well, so anytime I say 2x, right? 2x is just saying x times x.
Okay, yeah.
So whenever you have things all being multiplied by each other, you can switch the order however you want, okay?
Okay.
So instead of saying x times 2 times x, I can say 2 times x times x. You see how like I move the x over? And then what's x times x?
Squared x.
Good, x squared. So this is 2 times x squared. And then another way to write 2 times x squared is just to write 2x squared.
Okay.
You see how that works?
Yeah.
Yeah. So when you got things multiplying, I know because this always trips people up because people are always like, oh wait, is it 2 squared x squared? You know, and it's not. It's you take whatever the variables are, you multiply them together, and then you multiply by whatever the numbers are multiplied together. So here's another quick example. Let's say we had 3x squared times 4x to the third, okay? How do we think we do this one? So the first thing you do is like, what's the 3 times 4?
3 times 4 is 12.
Good, man. 12. Okay. So then that leaves you these two, right?
So it's 12x x squared.
So not quite. So now I have x squared times x to the third. So this is another thing. So you see how math all like builds on itself? It's all like you have to understand all the previous stuff. But if you have, for instance, x squared times x to the third, this is equal to x to the 2 plus 3, which is equal to x to the 5th. Have you seen that before?
Yeah.
Okay, good. Yeah. It's okay if you haven't, or even if you forget, like just a little refresher. So anytime you have...
Yeah, you're refreshing my mind right now.
Good. Anytime you have things exponents and they're multiplying together, you add the exponents. So this ends up being 12x to the 5th. Okay?
Mm-hmm.
All right. So I always do like little side lessons. When I see something where I'm like, you need to remember that, or you might have forgotten that. That's what I always like. I'm like, let's take a little side lesson to it. Okay. So let's go back to here. So 2x and x multiplied by each other, what's that?
2.
Yeah.
I forgot. Hold on. Oh, 2x squared.
Good. Very good. All right. Then let's do another part of the square here.
So is what is it? X and negative 2?
Yeah. So what's that? What's x and negative 2 multiplied by each other?
Oh, negative 2x x squared.
Just negative 2x. See, because there's no x here to turn it into x squared. It's just negative 2. Okay. Then what's another one?
Plus 4 2x.
Mm-hmm.
Plus x?
8 times x.
8 times x. So it's 8 squared?
No, it's just 8x. Just 8x. So let's look what happens here, Mel. So you got 4 times 2x, right? This is the same thing as 4 times 2 times x. Let's do the 4 times 2 first, right? That's just 8 times x. And then 8 times x is just 8x.
Oh, okay, yeah.
You see how that works? Yeah. The only time things will start becoming x squared and whatnot is if you have another thing with x multiplying by it. So here we had x times 2x. This is the same thing as like 1x. So 2x times 1x is the same thing as 2 times 1 times x times x. X and x is x squared. So that's 2 and 1 is just 2. That's why it's 2 times x squared, which is then just 2x squared. Okay? All right. What about this 4 and this minus 2?
Trying to remember that method that they show us about plus and plus is negative.
Okay. Yeah. So plus times plus is a positive. Plus times a negative is a negative. Negative times a negative equals a positive. That's the rule.
Yeah. So it's 8 negative.
Good. -8. Very good. All right, and then what's the next step we do with all this?
I believe you create an equation with it.
Good. So what would the equation be?
8. No, it's 2x.
Good.
Squared.
Mm-hmm.
And negative 2x.
Good.
8x and negative 8.
So plus 8x minus 8.
Plus 8x.
If there's nothing in front of it, you can just put a plus. You know. Okay. Then the last step.
So it's 2 squared.
Good.
With
2x.
2x.
So yeah, what terms do we have to combine here now?
I'm completely lost.
All good. Let's remember when we're grouping terms, right? We're looking for things that have the same like level of x. They call it like the power.
So it's negative 2x.
Good.
And negative 8.
Well, negative 2x and positive 8. Yeah.
And
so what's negative 2 and positive 8? What does that become?
Positive 6.
Good. Plus 6x. Good. And then
minus 8.
Minus 8, dude. Done. Yeah, nice, dude. Lit. Okay, cool. So that's expansion, okay? So that's all the little back work we got to do in order to get you to what the real thing that you originally had your homework on, which is factoring. So factoring is like reverse expanding, okay? So I'll show you what I mean by that. So let's say, for instance, you had x plus 1 times x plus 2, right?
Mm-hmm.
You know that, this would end up equaling x squared plus 3x plus 2. Because I just did all the Punnett square stuff in my head. But that's what eventually it would become. So this is what we call expanding. Factoring is when you take something like this x squared plus 3x plus 2, and then you somehow turn it into x plus 1 times x plus 2. It's like reverse engineering it. Okay?
Mm-hmm.
So I'll show you how you do this. So let's see, which one did they give you? X squared plus 8x plus 15. Okay. So the example they give you for one of your homeworks is this. It's x squared plus 8x plus 15, and then they say, factor. So you could try to keep guessing, right? Which two things you need to multiply by each other to try and get this x squared plus 8x plus 15. But doing so would be very it would take a lot of time. You'd be like just guessing like crazy. It'd take a very long time to do it. So there's a method for being able to factor. Do you remember what your teacher said? Anything about it? Did she explain it at all?
No, she didn't. She just gave us a word problem. And she put us in separate rooms.
What, dude? What?
Yeah.
Oh, in like these Zoom rooms or some shit?
Yeah.
Dude, it's such garbage. Oh my god. Okay. All right. Yeah. So here's the quick way to do it. The way to do it is you need to figure out what two numbers. What two numbers multiply to 15, but add to 8. Okay? This is the trick that happens. So you look at whatever this number on the right is, right? Without the x on it. And you need two numbers to multiply to 15. But you also need those two numbers to add up to whatever the number is in front of the x, which in this case is the 8. So this can also be kind of a puzzle, right? Because you're like, fuck, which number is multiplied to 15 but add up to 8? The easy way to do this is just to write out what the factors of 15 are. Did you guys ever do like greatest common factor and all that? GCF, LC, whatever, LCM?
Yeah, but I don't remember, to be honest.
I don't remember it either, honestly. It sucks. So you just write out, for instance here, what are numbers that multiply to 15?
3 times 5.
Good. So you got, 3 times 5. What are some other numbers? There's only one other number that actually really does it. 1 and 15.
Oh, yeah.
Okay.
I'm really bad with multiplication.
No, it's that's a tricky one that a lot of people don't actually really remember. They remember 15 times 1, yeah. And actually another set that would really work would be -3 and -5. Because when you have two negative numbers multiplying by each other, that makes a positive. Okay?
Mm-hmm.
So then the next thing to do is to check, okay, which pairs of these numbers add up to 8? So let's look at 3 and 5, what does that add up to?
8.
Yeah, good. So it turns out that this 3 and 5, 8, that's actually what our answer is going to be, but let's look at what the other ones would be. So 1 and 15 would be 16, -3 and -5 would be -8. So this ends up being the set that we want. So the two numbers that we want are the 3 and the 5. Okay?
Uh-huh.
So then what you do is you just write it like this. It's x plus times x plus, where these are the numbers you have. So this is the 3 and this is the 5. And then you're done.
Oh, you for real?
Yeah.
Oh my god.
You just got to figure out, again, the numbers that multiply to this, but they got to add to this, and then you just dump them in here. And then this is the answer.
Wow.
Yeah. So here, let's try a little bit of a harder one. X squared minus 16x plus 48. So let's say we had x squared minus 16x plus 48. Okay.
Mm-hmm.
So what's the first step here? If we say like we factor this.
Okay. I'm so slow right now.
No, it's good. It's good, man. So if we go back to the other page, remember, we got to identify first what number we need things to multiply to and what number we need things to add to.
Oh yeah. What two numbers multiply by 15 and but add to 8?
Good. So here we need them to multiply to what?
I know that 6 times 8 is 48.
Uh-huh. Yeah. So here. Multiply to 48, right? That's our first thing. Multiply to 48, okay? So you're right. 6 times 8 does multiply to 48. But when you add them up, what do they need to add up to?
16.
Negative 16.
Negative 16.
Yeah, so you can't forget this minus sign right here. There's a minus sign in front of it. So in the other one, we had a plus sign in front of it, which is why we said it just had to add up to positive 8. But here it has to add up to minus 16. Okay? So 6 and 8, what does that add up to?
14.
right? So that's not my minus 16, so that doesn't work. So we gotta find another one. So we gotta find more things that multiply to 48. What are some other things? This is where, like, sometimes, Mel, the easiest way is to start at the lowest number and just work up. So the lowest one we have is 1 times 48, right?
1 times 48.
What does that add up to?
Oh, 49.
49, right? So we're, like, really far away. And even so here's actually an easier thing we can do. We know that it needs to be negative, right? Which means we probably need these numbers to subtract from each other, right? And the only way to do that is to have -1 times -48, because -1 plus -48 is -49. So because this is negative and we need these to add up to be negative numbers, we're going to do the negative factors. Do you see how 6 times 8 is 48, but -6 times -8 is also 48, because a negative times a negative is a positive.
Yep.
Okay? All right. So what about -2? 2 times what gets you 48? Or, sorry, like, what times 2? Yeah, what times 2 gets you 48?
Times 2 gets you 48. 24.
24. Good. Very good. Nice. So we'd say -24, okay? But what do those add up to?
Oh, fuck.
What does -2, -24 add up to?
Positive 20... 26?
No, -26. So -2 minus 24. This is -26. Right? This is -49. This is -14. So we haven't hit it yet. Okay. What about -3? What times -3 gets you 48? Another way to do this is do 48 divided by 3. 16, good. So this is -16. So what does -3 and -16 add up to?
-19.
19, right? Still not there. This is why this is one of the harder ones that she gave you. Okay, what about -4?
-12.
Good. -12. What's -4 minus 12?
-16.
-16. Ah, look.
So there.
That's what we fucking wanted, right? You're like, bingo. Yeah. Ding, 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 ding. I need to get a soundboard like Dave has. I need to...
That's gonna be
That'd be lit, just like...
That would be perfect.
Right? Something's just like, oh my god! Dude, I'd have too much fun. Alright, good. So now we found it, right?
Yeah.
So what is our final answer then? What do we write?
Parentheses.
Good.
X squared -4.
So it's just x minus 4.
X minus 4. Parentheses. X -12.
Good. -12. Good. There you go. That's it, dude. That's how you do it.
Oh, okay.
Right? Yeah, I know, dude. It's like exhausting. You're like, oh shit.
And then she goes like 5 or 6, something like that.
Yeah, so let's, here, she gave you some other ones that aren't so bad. Let's try this one. X squared plus 10x plus 24. Alright, so she said 24 plus 10x plus x squared. Okay. So this is written like backwards, right? So the first step is to write it in this way, because this is easier for you to see, what it needs to multiply to and what it needs to add up to.
Yeah. So I have to find something that
good
times That equals 24.
So it multiplies to 24.
Yeah. 6 times 4.
Okay, good. And then it needs to also do what?
Be positive.
It needs to be positive, and it needs to add up to what?
10.
10. Good. So I think you already said the answer, right?
Yeah.
Right? See how this is easy? You can guess them sometimes. 6, 4, adds to 10. So what's the answer?
So it's x plus 6
Good.
and x plus 4.
Perfect, dude. There you go. Nice.
So they're trying to trick me with an equation.
Yeah, they wrote the
backwards.
equation in like a non-standard ordering because they're trying to fuck with you.
Ah.
Yeah. Nice. Let's see. Oh, wait, what the shit? She gives you this one? X squared minus 5x plus 3. Oh, actually, this one does work. Minus 5x plus 3. How would we do this one?
So this one. Yeah, well, okay, what the hell?
This one actually isn't factorable. She gave you like a trick question on this one. Because let's think about it, dude, right? You need things to multiply to 3.
I need something to equal that equals to -5.
Right? But adds up to -5, right? So the only things that multiply to 3 and that are negative, right, is -1 and -3.
Yeah.
But that only adds up to -4. So this one is one where we say, like, this is not factorable.
So you tell me okay, never mind. Yeah, that's straight up weird.
Yeah. If you go through all the factors, she shouldn't give you very many like that, but if you go through all the factors and you're like, wait, none of these add up to what it needs to be, then it just, you can't factor it.
That's an odd number.
Yeah, you can have things add up to odd numbers. You know, that's still fine. So here's an example of one that does. So let's say we had x squared minus 5x plus 6. So now you need them to multiply to what?
So it's 3 and 2, and they have to be both negative.
Good. So it's minus 3
and that
minus
equals
2.
-5.
Yeah. Do you see how that works? Minus 3 minus 2. So this is x minus 3. So that's a case where, like, you can have this be odd. You know, you just need them. You just need the factors to work out.
That's pretty simple.
Right?
Pretty simple one. Yeah.
Nice. All right, cool. That's like the first part of what you got to do. The second part is, which we can save this for another time, dude. But like,
you're done for that.
Yeah, is doing these ones. These ones. See how now there's a number in front of the x squared.
Okay, what the hell is that?
I know, right? So your previous ones that you only had x squared, right?
Mm-hmm.
Which is easier to do. It gets a little bit trickier when we start putting numbers in front of the x squared. It's not that bad, but maybe let's. When is this due for you, Mello, dude? When's it due?
Like in 2 weeks.
Oh, it's due in 2 weeks. Oh, cool. Oh, nice, lit. All right, let's just save this for next week then. You know, so because I always, one of my philosophies with teaching also is like you can't teach someone too many things at once because you won't remember all of it. You gotta like kind of slowly get it. So
barely sunk in like the first part, and then when you memorize the first part, you have to memorize the second part.
Exactly right. Yeah. You gotta do it slowly in steps. Otherwise, you'll completely forget. So you should be able to do the homework questions where they don't have anything in front of here. So you should be able to do the rest of these homework questions. So maybe try doing those over the next week, and then next week we can go over it being a little bit more difficult with putting the numbers in front of the x squared. Cool. Was this helpful? Do you understand some shit?
Oh yeah, it was really helpful.
Okay, nice, dude. All right, I gotta go teach a kid in fluid dynamics now. But
hey, how long until when can you play?
I can probably get on at like 6. I gotta go to dinner at like 7, so I can probably play for a quick round or two at 6 o'clock my time.
So for me, it's 7.
Yeah. Oh yeah, because you're on El Paso time. Yeah, probably at 7. Yeah.
I bet. Perfect. Yeah, I'm down.
All right, dope. Thanks for joining, dude. I'll see you later, dude. Peace.
Yeah, see you later, bro. Thank you.
Peace, guys.